Good morning, AFM class. Today you're going to be moving on to Chapter 6, and we're going to skip the first couple of sections and start with Section 3. We're just going to do a couple of lessons in this chapter today, and then Monday and Tuesday we'll be in Chapter 6, and then we're going to move on to Chapter 7. But I just want to review a little bit about exponents and logs with you today before you start your assignment. Now, this is just a quick review of exponent rules before we get into the log stuff. I just want to remind you that whenever you have a base raised to a certain power, there's different exponent rules that you can use. So here, any base raised to the 0 power is always going to be the number 1. Whether that base is a variable, a number, a fraction, a negative base, whatever it is, any base raised to the 0 power is a 1. We also have negative exponents. Whenever you have a base raised to a negative exponent, it's almost as if that base is going to get relocated down to the denominator. So an x to the negative 3rd power is the same thing as 1 divided by an x cubed. Okay? It would be the same thing if you have a negative exponent on the bottom, then you just relocate that base up to the top and you can drop the negative. Remember, when you are multiplying bases, if it's the exact same base, the shortcut here is whenever you're multiplying, you can just add exponents together. So m to the 5th times m cubed is really an m to the 8th. When you are dividing with bases, you can just subtract those exponents. So n to the 9th power divided by n to the 6th power. If you subtract, that would be an n cubed. And then you also have, when you are raising powers, to other powers. So in this example, my entire base is this monomial 2y to the 5th, and that entire base is getting cubed. Now that means that your 2 is getting cubed, so 2 to the 3rd power would be the number 8, but your y to the 5th is also being cubed, and when you have a power and you raise it to another power, the rule is that you multiply. Okay, so very quickly wanted to review the exponent rules with you before we get to logs. Now you should have done logarithms last year in Math 3, so this is a very quick review. This should be a fairly short video. If I have this base of 2 raised to the 3rd power, that is equal to 8, okay? So when you're going to rewrite this from the exponent form into the log form. Also tonight in your homework, you're going to write some from log form back to the exponential form. So here's the trick. Whatever the base of your exponent is, that should also be the base of your logarithm. Now, in the common log, we usually have base 10s, but you can have other bases other than a base 10. So whatever the base of your exponent is, that is the base of your log. The exponent itself is what your logarithm should be set equal to. So a 2 cubed is equal to 8, that is the same thing as a log base 2 of the number 8 is equal to the 3. Now, I think it's easier to go in the other direction. If I start you out with a logarithm, you're going to start out by writing the base of 2, raise it to the 3rd power, and then you can set that equal to an 8. Okay, so I got a couple more rules here, and again, the beauty of the videos is that you can always stop and pause and take notes, okay? So here's just some generic rules. A log base b of y is equal to x. If you're going to rewrite that in the exponent form, keep the same base, the base of b, which I write here, raised to the x power is going to equal that y. You can do the same thing for natural logs. Natural logs are going to have a base e. E is a number, it's like 2.7 something. So if that's not written there, you can actually insert the number e. So log base e of y equals x. That is the same thing as the base of e, which I write here, raised to the x power is going to equal y. There is also a base change formula that you can use. If you have a base that's not a base 10, then you can use this formula. So log base b of the number m is the same thing as putting in your calculator the log of m divided by the log of b. And I've done an example for you. If we evaluate log base 2 of 32, that's the same thing as the log of 32 divided by the log of 2, and you can just put that in your calculator. Log of 32 divided by log of 2 is the number 5. Some of your homework problems are going to ask you to evaluate some of these logs, and that's one of the tricks that you can use. Okay, so I'm going to walk through a couple of examples with you. Your homework tonight is to do 1 through 25, every other odd, but you only have to do A. So I'm going to do a couple of examples of the B. Okay, this is on page 405 in your textbook. What we're doing here is to rewrite this log into the exponent form. So here's what we're going to do. The base is a base 5. So I'm going to take that base 5. I'm going to raise it to the 0 power, and then I can set it equal to 1. The base 5 raised to the 0 power should equal the 1. So that's how I write it in exponent form. Okay, let's do another one. Log base 8 of 512 is equal to the number 3. If I'm going to rewrite that, I'm going to start out with my base of 8. So my 8 raised to the 3rd power is equal to that 512. Okay, one is in the log form, the other is in the exponent form. And it's true that an 8 raised to the 3rd power, 8 times 8 times 8, really is 512. So your base raised to that exponent is equal to that number. It's like a little loop here. Do one more of these. So I have log base 2 of the fraction 1/16 is equal to a -4. I'm going to rewrite this thing as an exponent. So I'm going to start with that base 2 raised to the -4th power is equal to the 1/16. Okay? Now, let me very quickly explain this to you. Remember we said when we were reviewing our exponent rules that if you have a negative exponent, it's the same thing as moving that dude down to the bottom. So really a 2 to the -4th power is the same thing as 1/2 to the 4th power. And you can see that it really is 1/16. 1/2 to the 4th power, 2 times 2 times 2 times 2 is the number 16. So the first couple of problems in homework, you are rewriting from the log form into the exponent form. Then you have a couple of problems that you're going to go in the other direction. For number 7 and number 8, I've already got this in the exponent form, and we're going to rewrite it as the log. Now remember, the base of your exponent is the same as the base of the log. So in this example, I'm going to have my log base 10. That's the number that we're taking the log base 10 of, and it should be equal to your exponent. Okay, so the base of 10 raised to the -3 power is equal to the 0.001. That's the base of the exponent. It's the base of the log. The exponent itself is what your log is set equal to. Okay, let's do one more. Base of 81 raised to the 1/2 power is equal to a 9. So I'm going to have my log base 81 of the answer 9 is equal to my exponent. Okay, so what you're going to do tonight is to practice 1 through 25, every other odd problem, and you can do A. I'm going to include the answer key on the Google Classroom, and also the answers are in the back of the book since I have assigned you the odd problems. Remember, if you have any questions, please don't hesitate to email me. I can give you my cell phone number. We can talk one-on-one if you have any questions. Good luck.